All right, so we're going to look at some different functions and say, hey, is this function one-to-one? What's the domain? What's the range? Kind of all a good review of this chapter. So we look at, this is the graph of 2 to the negative x, which if you remember your exponent rules, you'll know that that's the same as 1/2 to the x if you want to think about it that way. But either way, we can look at this pretty quickly and say, hey, every horizontal line that I might draw through here, through the graph, is only intersecting in one spot. Now it does get really, really flat over here, but this is what we'll talk about in more detail later, is a horizontal asymptote where the graph keeps getting closer and closer and closer to zero, but it doesn't actually ever go horizontal. So this function is one-to-one. We can see from the domain, we can see from the graph, rather, that our domain is all real numbers. We can also look at here and we can say, okay, is there any time where I'm going to divide by 0? No. Are there any square roots? No. So we don't have to worry about anything with the domain. Now, visually, for the range, we have to really look at it visually. We can see it's going up to positive infinity. There's no gaps, but our lowest y value is getting really close to 0, but doesn't actually get to it. So our range is going to be 0 to infinity. So what about this one? This one's a cubic, and I kind of already gave this away in the earlier video. We look at this one and we say, you know, this one is not going to work, right? Because we have, it just takes one, but we happen to have multiple horizontal lines that we can draw through this graph that intersect in more than one spot. So this one is not one-to-one. We're going to talk about domain and range first and then talk about restricting the domain. So our domain on this one, again, you know, it's a polynomial. I don't know what happened there. There's no divide by 0, no square root of anything, so we don't have to exclude anything. So we're going to be all real numbers. And we can see from the range here that it's going down to negative infinity. It's going up to positive infinity. So we're looking at all, and there's no holes or anything in the middle. We're looking at all real numbers for it as well. So even though it passes horizontal line in a couple of places, because there's even just one place where it intersects the graph, where a horizontal line intersects the graph more than one place, it's going to be not one-to-one. Now, the question is, can we restrict the domain? Can we take a smaller chunk of this graph to make that part of it be one-to-one? And the answer for that is yes. In that case, I'm going to switch colors here. We could say, you know, I see that I can't draw lines. No, I can see that kind of if I look at any one of these three parts, this one, right, that part kind of in the middle, or the one on the left side, or the one on the right side, any one of those three pieces by itself would pass the horizontal line test. So we could restrict the domain to any one of those pieces. We could say, okay, negative infinity to -1, or -1 to +1. And actually here, we can include those endpoints on any of the parts. So this could be, these could be square brackets, or 1 to infinity. Any one of those three pieces of the graph by itself would pass the horizontal line test and therefore could be inverted. Okay, so what do we got next? We got one more of these, maybe more, I don't know. So we've got another function is f of x equals 8 over x, 1-to-1. And we see the graph here because that's by far the easiest way to check. And we see that whatever lines I might draw through here are only going to intersect at one place. We do have another horizontal asymptote because this is going to keep going closer and closer to the x-axis, but never actually go horizontal. So yes, it is one-to-one. What's the domain? We need to throw out anywhere where we divide by 0, which is going to happen when x equals 0. So we cannot have x equals 0 in our domain. And our range, we're going to do the same thing because we notice that there's this gap here, that the function's we're never going to be able to get 0 out of the function. So we're going to say the set of all y such that y is not 0. Or you can write an interval notation, right? Negative infinity to 0, union 0 to infinity. Your choice. And now we're at the 5-6 minute mark, so let's pause for the next video.